So we'll start with our quick look at the calendar. Today we talk about cryptography. We're going to spend 2 days talking about cryptography, today and Monday. And also note that the voting project is due today, so hopefully you've either finished it or you put it in the folders for me. I do accept late projects, but there is some kind of lateness penalty that I don't remember off the top of my head. But the idea is get it in as soon as you can if it's not in on time, all right? In theory, I will turn around and get these projects to return to you on Monday. And so hopefully if you make any mistakes on the project, you'll learn from them and not make those mistakes on the test, which is coming up soon. This next week is going to be a little bit choppy for us. Here's our class on Monday, regular class. Wednesday coming up next week is not in the calendar. On October 1st, there are no day classes at GCC. It is a professional day, meaning the employees come in, but the students don't. If you do have a Wednesday night class, you come in Wednesday. I think it's 4 o'clock or later is the night class. So if you have a Wednesday night class, you come in. Wednesday day, no classes. Then October the 6th is our review for our test on October 8th. Questions on the calendar? Okay. So we're going to jump into cryptography, and we're going to kind of skip some of the text that I've written up here, but I do just want to give credit where credit is due. The material that we're covering today in next class is not from your textbook. You won't find it in your textbook. It's from materials created by James Hamblin, so thank you to James. All right, so let's jump down to number 3, and we'll start with Eric. Thank you, Leah. Okay, so lots of vocabulary there, encryption, decryption. Cipher is just going to be some rule that we're going to follow to take a message and encode it, make it so that only the person that we want to read it will be able to decode it, to read it. But there's this key word here, reversible. So what does it mean to say it's reversible? Okay, so what if the phrase that we're trying to encode is math, but we don't want to let just anybody know how awesome math is. We want to keep it to just our select few friends. And so I'm going to come up with this great way to encode the word math. Every letter becomes the letter R. So here is my encoded message, yes? What's the problem when we give our friends that message? There's no way they don't know anything other than it's a 4-letter word, right? And so that encoding method is not reversible. You can't go backwards, which makes it fairly useless, all right? So we got to have stuff that we can undo. Okay, so moving on to 5, Matthew. Jennifer, 5. Thank you. Jennifer, 6. Keep going. Take. Okay, so here's a few examples of the Caesar cipher written out. A becomes D because you go 3 letters ahead. So starting at A, you go B, C, D. So every A becomes a D, every B becomes a C, D, E. Yep. And then when you get around to the end of the alphabet, for example, the letter Y, you're just still going to count 3 ahead, but you're going to wrap around to the beginning of the alphabet. So starting at Y, we go Z, A, B. And so Y becomes the 3rd letter, which is B. All right? Okay, let's go to 7 here, Jeff. Thank you. Zeke, 8. Okay, does everybody have their cutouts ready? Do you need scissors? Raise your hand if you need a pair of scissors. Where are the scissors now? Send them this way carefully, please. Thank you. Ashley, you can send them to that back corner table when you're done. Okay, so number 9, when you're ready with your cutouts, which is most of you, what we're going to do is encode this message, attack at daybreak. So in order to do this, you're going to take your 2 alphabets, right? You got your 2 alphabets, and you're going to make it so that the left-hand alphabet, the small, the just one copy of A through Z, make it so that the A in the small copy matches up with the D in the big copy. Does that make sense? Match up the A with the D. So the small one goes first on the left, and when you read right across, it should say A going with the D. So let's get the small one first.
Okay. But no, like my question was going to be, so when you do the first letter attack,
yes,
A in attack,
yes,
do you do this A or this A?
We're going to do this A on the small guy
so
here.
It's actually.
So A goes to D, and then we'll do the T's together, and then you guys will continue. No spaces. Okay, so what do we do? Okay, so where does the letter T go? W, and then the next T is also W. Okay, so take a minute or so to encode this message. Skip right over any spaces, and then we'll come back together when you're done. You ignore the space. One long word, ignore the spaces. So in order to make comparing easier, and in order to make the materials easier for us to read, we typically write the words out in blocks of 4 letters. So go ahead and rewrite your answer. So it's not just one long word, but what's the next letter after this D? F. So go ahead and rewrite your answer so that it's blocks of 4 letters separated by spaces. Blocks of 4 letters separated by spaces. So right there is Jackie's answer written out in blocks of 4. It's okay. Just makes it easier to read. Did anybody agree with this one?
I do.
All right, so we got a bunch of people agreeing here. So if you missed a letter, try to go back and find it, but let's go ahead and move on to the next page. Okay, so number 11, we'll go to Megan. Keep going. Oh. Okay, so here's something that was encoded in blocks of 5. It doesn't make much difference. Keep your alphabets in exactly the same place, but now instead of starting with the short alphabet, you're starting with the long alphabet and going right to left. Everybody see it? So start with the long alphabet, 1 letter at a time. Once you get the 3rd letter written down, check with your neighbors to make sure everybody's on board. And then if you feel like you're getting the phrase, don't say it out loud. You're going to ruin the surprise. So what several groups are realizing is that there's really one way to go wrong here, and that's to not understand which of the 2 alphabet things you have to read first, right? So for me, I always put the short one on the left, and I go left to right when I'm encoding and right to left when I'm decoding. You just have to be careful and make sure you're going in the correct direction, otherwise you get gobbledygook. Okay, let's go to number 12, Christopher. Okay, so substitution just means that every time you see one letter, it always gets replaced by the same thing. So for example, these 2 T's right here, what did they both become for us? W's. And of course, every T becoming a W, like we better be consistent. But it turns out there are other encryption methods where you don't consistently replace every T with the same exact letter. So let's move on to 13, Sarah. That's right, because we know that there are certain letters that are far more common in the English alphabet than others. So if you give me, have you guys ever done the cryptoquote in the newspaper? Right, they'll give you like some long phrase, but it will be gobbledygook, just like what you just saw there. And all they tell you is that it's a substitution thing where every time you see one letter, it always means the same letter. And so you can just look and try to find the letters that appear most common. Probably the word the is in there someplace. So you check the three-letter words and you can undo. And that's the whole point, is that you can figure this thing out even though it's encoded. And so like people have studied the frequency of letters, and we can tell you exactly what the most common letters are. E is the most common letter used in words, then T, and then A, and you can use this kind of information to hack a substitution cipher. So substitution ciphers are really easy to use, but unfortunately they're also really easy to figure out. So let's go down to 16, which says the bifid cipher uses a device called the Polybius square, and that's what we're going to fill in here. So what we'll do in the left-hand box is we're going to fill in the alphabet, A through Z. However, how many letters are in the alphabet? 26. How many empty boxes are up there? 25. We're going to not write the letter J. It's a letter that's hardly used at all, right? There aren't a lot, like it is a very infrequent letter that's used. So yeah, J and Z are both down there. It looks like Z maybe is a tiny bit lower. I'm just telling you historically. We can get rid of Z and keep J if we wanted to, but I'm telling you that historically. So what we're going to do is we're going to write the alphabet in order here. A, B, C, D, E, F. Keep going. When you get to the letter J, just don't write J. Write the next letter. Okay? So completely skip right over J. So it goes H, I, K is the last one in the second row. No, just in one. And you probably did it right if you land on Z in that last square. Okay, so it's not really clear how we're going to use that to encode some stuff, but let's talk a tiny bit more about the square idea. What we're going to do is instead of, so we're going to write the entire alphabet just like we did here, skipping poor letter J. But instead of writing them starting with A, we're going to use a keyword to start up here. And so for example, down here, it says use the keyword confidential. So what we're going to do is we're going to write the letters of the word confidential right here in the beginning of our square. So C-O-N-F-I-D-E, and then pause when we get right there. So we're just writing the word confidential. Confidential is going to be given in the problem. Stop right there. What's the very next letter? N. But we've already put N in this square. Our job is to put all the letters A through Z once and only once. No repeats. So you skip right over the N because we've written it already. T, we have not seen. The next letter in confidential, I. Have we seen it? We have. Don't write it again. Next letter, A. Have we seen that? Nope. And then finally L. There. So we've got the word confidential, skipping any repeats, okay? And now we're going to fill in the rest of the box with the rest of the letters, all the letters that we haven't used yet in the word confidential. But again, you're not repeating anything. So the first letter would normally be A. Have you already written A? Yes, you have. So you go B. Next letter should be C, but it's already there. How about D? It's already there. How about E? Already there. F? G? Not there. H, I is there. J, we skip. K is next. Keep going very carefully. And if you do it right, you should land on that Z at the very end. If you don't land on Z at the end, there's a mistake somewhere. I'm sure your first grade teacher will be happy to show you the alphabet again. Right. So just take your time. No repeats. Okay. So we still haven't talked at all about how this square is going to help us encode anything, but I think we're ready to do that right now. Any questions on filling in this bifid, the Polybius square it's called? Okay, so let's go to the next page. And we are going to do number 20. The process is written out up above, but we're not going to look at the process. I'll just explain it. So we're going to do number 20. So number 20 says we're going to encode the message retreat. It turns out that in order to use this new method that we're about to discuss, we need the message to have an even number of letters, but retreat has an odd number of letters. So we're going to tack on like an invisible X at the very end of it. And then when somebody reads this thing and it says retreat X, we figure they're smart enough to understand that it means retreat, right? So here's our thing to encode, retreat with an X at the end. Here's the square exactly that you had on the previous page, right? You can see confidential at the top and then the rest of the letters. So here's what we do. One at a time, we're going to go through the letters in the word retreat, and we're going to pick them out by just giving the coordinates, row and column. So for example, the R appears only once in this square. Where is it? Which row? Fourth row, third column. Make sure you put 4, 3, not 3, 4. Fourth row, third column. And then you grab the letter E. Where is it? 2, 2 is good. Go ahead and fill in the rest of those. Check with your neighbors. Okay. So QAELGHAH is the encrypted word. That is supposed to tell this person retreat with an X at the end. So let's come back to Jen's question. She said, why did we need an even number of letters? Yeah, we got to be able to pair them up. And if we didn't have this last column, then we wouldn't have a pair, right? So that's why we have to have an even number of letters. So now we're going to go the other direction. This is one direction. Now we have to be able to reverse it. But first, before we decode, let's answer number 21. It says, is bifid, that's what we just did here, a substitution cipher? Meaning, did every time you had one letter, did it get replaced by the same letter? So take a look at the letters R and R, here and here. What did the first R become? Right, first letter is Q, and what about the other R? L. And this is good, because if it's a substitution cipher, it's really easy to crack. But here, the R's did not get consistently replaced by the same thing. It makes sense that they didn't get replaced. This was a really complicated thing we did in order to encode this message. Because it's fun. Okay, so let's see if we can go the other direction. Any questions going this way? Okay, so let's try going the other way. Here we go. 23. So here's our message, Sawa, and then some stuff. So that has been encoded using a bifid cipher where the keyword is Schwarzenegger. So that has to be given to us as part of this message. We're not using the word confidential every time. We've got to have a different keyword. So what we're going to do first is fill in Schwarzenegger's name into our square over here. So what do we do here? SCHWARZEN, and then tell me what happens in the next square. We don't do the other E because we've already done it. G, and then what about the next G? Don't write it. E we've already seen, R we've seen, that's it, okay? So now carefully pick up in that first blank with the rest of the alphabet. Leave J out, always leave J out. Never using J. Now typically, you know you did this right if you get what letter in the last square? Z. What letter are we going to get in the last square here? Is Y, because we already had a Z in the square. You might miss the fact that you've already written a letter, or you might skip a letter that you shouldn't be skipping. I made a mistake a moment ago when I was filling this in. Sue Ann, what did I do? Yeah, I think I forgot to put the I in there, and then I filled in the next row, and then somebody said, hey, that's wrong, and if they didn't, then I would have gone all the way and not gotten to my poor Y. It's easy to make a mistake, but the good news is it's really easy to know that you made a mistake somewhere, and then you just say, well, shoot, and you go back and you fix it. Okay, so now we're going to take this idea and decode the message. So first thing to do is this whole row column thing, just like before. Now this is a long message, so write kind of small. So rows and columns. So the S is the first thing I see. Where's the S? 1, 1. 1, 1. Next one is an A. Where's that? 1, 5. So very carefully, and I'm telling you, you're going to want to squeeze it into about the amount of space I've done up here. See if you can translate the rest of that. And again, check with your neighbors. We got to get these perfect if we're going to decode the message. Okay, so here we go. Everybody's with us? All right, now we're going to do this decoding business. And we say, okay, how did we get to this? Like, how did we get to this stuff right here in the, like, right in there? Where did this 4-2 come from? It came from 4-2 horizontally. And then that 2-4 came from 2-4 horizontally. So we're going to go until we get to the middle, which is right there. Why am I writing a break there? Because then we went to the next row. Do you see that? Like the 2-5, the last thing I circled, came from 2-5 up here. But then we just went to the next row. So then once we get past the halfway point, 3-2 is getting written horizontally in the bottom row. Yes? So let's first find the halfway point, and then we'll write this stuff out. Okay, so halfway is after 8 letters. Where is that? 4 here? Okay, so all we're going to do is take the columns and make them rows. So first column was 1, 1. It becomes as a row 1, 1. The next column, 1, 5, becomes as a row 1, 5. Do we see it? There are a lot of ways to do this wrong. All right, before there's a revolution, here we go. We're going the opposite direction from what we did before. Before, we took the rows and we made them columns, but we're doing the other direction. So we got to take the columns and go back to the rows. Here we go. Okay, the next column is?
Why are we skipping the other process?
Which process? So we're currently here. Like somebody already took the things that were rows and made them columns. We have to go back. Yeah. All right, here we go. What's the next column? 1, 4, which becomes a row. 1, 4. And so you keep copying columns to rows. Write kind of small. So I've got a 3, 1 and a 3, 5 at the end of the first row. And then what do we do with the next 3, 5? Next 3, 5 just goes to the bottom. Still writing things horizontally. But 3, 5 goes to the bottom. Make sure you line your numbers up. Numbers have to get lined up. Text messages get encrypted, so I appreciate that you're using this as a real world.
Yeah.
So
Putting this in the field.
Say it out loud.
Is that what it says?
All right, so go ahead and translate now.
I'm way behind.
Yeah, so we'll get you caught up. All right, but once we've got everything written out, you use that square again, and then are you able, don't say it out loud, but can you make sense of that phrase?
Yeah.
Yes, you can. All right, so Brendan, you see how we're translating back now?
HAS.
All right, so go back to the letters. Jen, don't encourage this guy. I'm translating here. And he just wants the answer. All right,
We got
so
to
what's
this
happening?
point, and I circled them like this, but that's wrong.
That's wrong.
I should have circled them this way.
Yes, and then write them horizontally. Yes, just like that.
And then written them
Yeah, so the first 1, 1 vertically
still be 1, 1
becomes 1, 1
next
horizontally.
to each other.
Yes, and the next
then
one?
1, 5.
Yes, keep going.
Then 1, 4.
Yeah,
Is that seriously? That is it.
I want you to translate here
I
using
did.
the square.
1 by 3. It's 1 by 3.
Yeah, H I think is the only one you looked up. All right, so
The eagle has landed.
And then
all right, so try number 4. It's just like the one you did. Okay, and then did we get Pat to the halfway?
I got to the halfway.
And so just start writing them down below now.
It says.
So that
Exactly, just like that.
So if it says use the bifid cipher,
Yes.
but it doesn't say which way you're turning it, columns to rows, rows to columns, which is default.
So it depends on which direction you're going. When you're encoding,
Yeah.
then we're taking the horizontal and making it vertical.
Okay.
But when you're deciphering or decoding, you take the vertical and you put it back to horizontal.
Oh my god.
Yeah, so try that one.
This is brutal.
Okay, so as you're translating, don't say the answer out loud, but do check with your neighbors to make sure. Yes, find the letters. Find the letters. Wonderful, don't show anybody else.
So am I supposed to do it like this? Like go like this?
Yes,
and then
1
the
to
half?
3, and then find 1, 3
So
is,
do it vertically?
yes, yeah, vertically now. So,
Okay.
right, rows and columns.
I said.
Yeah, it is stupid.
I can go current corner.
So
All right, so you got that one, Jeff?
Yep.
All right, so if you want to do one just like that, do number 4 on the next page. All right, so some speed demons are done. If you finish, move on to the next page. That's where the activity is there. Brendan, that's good. Leah, you got that one? Super. So you can start wherever you want. If you want to do one that's just like what you did, it's number 4.